Hi and welcome. My name is Marit van Dijk and I'll talk to you about reading code today. And the reason is that we spend more time reading code as developers than we do actually writing code. Many tasks involve reading code, like adding features, fixing bugs, understanding a new code base that we might need to work on, doing code reviews, learning about new technologies, and reading blog posts or books or watching videos, etc. In fact, developers on average spend as much as 58% of their time comprehending existing source code. And this is a quote from the book The Programmer's Brain by Feline Hermans. She's a literal professor of computer science education at Vrije Universiteit Amsterdam. And she wrote a book about what every developer should know about cognition. So she looked at a lot of research on how we learn code, how we read code, etc. So we spend more time reading code than we do writing code, but we hardly ever practice reading code, or at least not explicitly. And even when we do talk about readability, we talk about writing readable code and not actually reading code. Just for the record, this is not what my talk is about. So Feline is also a conference speaker. She spoke at Strange Loop 2019. Her talk was called How to Teach Programming and Other Things. And in this talk, she mentioned research from 1992, which is before I learned programming, probably before most of you learned programming. And the research was about teaching children programming or students programming. And they had a classroom of students. They divided them into 3 groups. The first group would write and read code. The second group would write code and read code, but with explanations of why certain design choices were made, why certain implementations were chosen, etc. And the last group would only read the code with those explanations. And what they found was that the second and third group that read the code with explanations were actually better able to reproduce the programming concepts that they needed to learn than the first group that only wrote code and read code without explanations. So reading code with explanations is a better predictor for learning the programming concepts than writing lots of code. And yet we learn programming by writing lots of code. And after that talk, someone came up to her and said, what if we did practice reading code explicitly? And that's how Code Reading Club was born, and they started it as an experiment. And I read or heard about it somewhere, and I was like, oh, I want to do that. I want to try a code reading club. And then I got really lucky because a friend of mine reached out and said, hey, we're starting a code reading club. Do you want to join? I'm like, yeah, I do. So we have a club of several people who live in different countries, have different roles, work in different companies, using different programming language, and we have sessions about once a month. We can't always make it. Some of us travel. So sometimes we have to miss them, but we've been doing that for about 2 years. So what we do in this code reading club is we take turns facilitating, and we bring a code sample. Finding a code sample that is 1 or 2 pages long and still has something going on is harder than you think, by the way. So we take turns facilitating, bringing a code sample. We usually print it on a piece of paper. And then we apply structured exercises to that piece of code to try and make sense of it. Sometimes it's a language you don't know, a domain you don't know. And so one of the things is annotating it on a piece of paper with colored markers is fun. The background for this slide is an actual result from one of our code reading clubs. And at least you get to play with colored markers, which you don't get to do a lot as an adult. So I'll give you some examples. Has anybody ever been to a code reading club? Okay, so I'll give you some examples of what we do. And I'll give you some examples of the exercises and describe them. So the first exercise that we usually do is called First Glance. That's literally what it is. We take 1 minute and we look at the piece of code and we write down what the first thing is that we notice about that piece of code and why. And what's really interesting in doing that exercise with some people is that some people notice something, oh, this looks familiar, this gives me a hint of what this might be about. Or this syntax is completely foreign to me, I have no idea what it means, and I need to figure that out before trying to make sense of the rest. I did this talk last week at Dev2Next in the US, and we had a smaller group, so I actually did an exercise with some code, but unfortunately the code was too small for the people in the back to read. So what they noticed mostly was the shape of the code, which is also interesting. So the next thing we try to do is identify components and relationships, so looking at variables, methods, instances, and how they're used throughout the code. And also, how do we determine, if it's a language that we don't know, how can we recognize variables, methods, etc. Turns out you actually can, even if it's a language and a syntax that's not as familiar. We also decide what the most important lines are in the piece of code that we're looking at, which is, again, especially interesting if you don't define upfront what most important means. I mentioned that we have people with different roles and backgrounds in our group. So the first time we did that exercise, we ended up with a very wide range of lines that we thought were the most important for different reasons. Some people picked, these are the most important lines because they help me understand what this code is about. So that might include the name of the class or a comment. Other people picked, these are the most important lines because they determine the flow of the code. So if I have these, I can draw a diagram of the control flow. That was me. Other people, we have a bunch of people with a tester background in our group, were like, these are the most important because something happens here that needs a bunch of test cases. So these are the most important for me to know what to test. And also what we found over time, as we had this club every month, is we started to converge on what the most important lines were, which was interesting. Finally, we might identify concepts in the code that either we know or don't know. And again, there would always be someone in the group able to explain something that was unfamiliar to others, and it would always be a different person. So it's interesting to learn from each other and with each other, and everybody had something to contribute. And even though we, apart from maybe the last one, the exercises don't really deal with what the code is about. The last exercise we usually do is we take a few minutes to summarize what we think the code is about. And by having applied these structured exercises, we're usually able to approximate quite well what the meaning of the code is or what the code does. So I really like doing Code Reading Club, mostly because I learned about the skill of reading code and deliberately practicing that. But even more because I loved getting other people's perspectives on the code, and especially sometimes people would really focus on a particular piece of the code that I kind of ignored as not as important, and it was really interesting to me. Why are they focusing on this thing, or even why did I ignore that, or didn't find it as important? So I also, it was really interesting to me to make my own assumptions about code more explicit and learn about how I look at code and why. I wrote a blog post about my experience and why I think you should try Code Reading Club that you can find on my website. I'll share the slides at the end. So what's also important about Code Reading Club is that we're reading the code not to judge it, but to try and make sense of it. And I think that that's an important mindset that we can all use. Because who's ever looked at code and thought, oh, that is really bad. I would do that completely differently. So anyone didn't raise their hand? Okay. So who sets out to write bad code? Okay, that's just a few of you. As a developer advocate, my job sometimes is to write the bad code and then to fix it. But as you noticed, not a lot of us set out to write bad code. So keep that in mind if you're looking at code and you think, oh, this is really bad. You know, maybe you learned new stuff. I've literally looked at code that I wrote 6 months ago and was like, no, that needs to change. It was when we first switched from Java to using Kotlin, And when you do that, you first write basically Java in Kotlin. Like if you're learning a foreign language, your sentence structure will be off. Someone is nodding in the front. You've been there. And then 6 months later, I was like, no, this Kotlin is really bad. We need to make this more idiomatic. So yay, I learned a bunch in 6 months. So, keep all of this in mind. Feline, in her book, which I highly recommend, by the way, I'm not getting a commission. You should totally all read it. It's very good. In her book, she mentions 5 reasons why code is confusing. She mentions a lack of knowledge, a lack of information, or a lack of processing power in the brain. And she discusses, so first of all, these are tied to our cognitive processes, so our long-term memory, what we know, our short-term memory, the information that we have available, and our working memory, how we can process that information at the time. Lack of knowledge can be either in the programming domain, so a language or syntax you don't know, programming constructs, algorithms, design patterns, or in the business domain, so business concepts or domain logic that you don't know. And Feline suggests that we can deal with this lack of knowledge by creating a list of the things that we don't know and researching those things. Now, who's ever looked at a piece of code and went straight to Google to go look what that meant and ended up down a bunch of rabbit holes? All of us, almost. Not just me, thanks. So it helps to create a list to keep you kind of on track on what the things are that you wanted to research, so you make sure that you don't end up down a bunch of rabbit holes. And also, Feline recommends that you memorize some of the things that you research if you actually actively need them. So if you need to store them in your long-term memory, because you'll need that information a lot, memorize it. It could be a particular syntax, it could be a particular business logic, whatever applies to you. Lack of information could be unknown details, library methods that you don't know the exact implementation of, unfamiliar names, especially if it's a domain that's new to you. Code that might be connected in unknown ways, especially if you have larger code bases, or there might be too much going on at once. Feline suggests that we can deal with this by chunking. Who's ever heard that you can keep 7 plus or minus 2 things in your short-term memory? Quite a few of you. Turns out it's actually less. It's more like 2 to 6 things that you can keep in your short-term memory. So if you can group them into a design pattern or a certain known thing, then you can fill more chunks with more information. So familiarize yourself with concepts and patterns so that you don't have to keep each individual part of a pattern in one slot, but you can group it into bigger chunks. Lack of processing power in the brain can be that there are too many processing steps or too many variables to keep track of. And we can deal with these with memory aids like a dependency graph or a state table. So a dependency graph could look like this. This is a piece of annotated code that is the result of a code reading club. I took it literally from their website. I have no idea where this code is from. Some of you might wonder. So you can mark the variables and how and methods and how things are used throughout the code to give you an idea of the flow. Or you can use a state table. I've deliberately used a very simple nested loop so we can all follow along, but I'm sure you have seen code that manipulates a bunch of variables that are hard to keep track of. A state table might help you make sense of that. Feline was writing another book called Code Reading in Practice, but unfortunately she put that on hold. But I managed to read an early access copy on O'Reilly, and in that book she mentioned 4 dimensions of code reading: structure, domain, concepts, and context. So in terms of structure, we know that code is not read linearly. We don't read it top to bottom. We don't run it top to bottom either. And in fact, the more experienced we are, the more we scan the code or the shape of the code to look for the thing we need, and then hone in on that and take it from there. In terms of domain, we can talk about the behavior and the data that the code deals with. In terms of concept, we discussed programming concepts or domain concepts. And then, of course, we have the context. Why was this application written? Where is it used? What's the place in the bigger landscape? What other applications does it talk to? But also maybe a bit of history. How did it grow to be the shape that it is today. So when we familiarize ourselves with new code bases, we need to look at the bigger picture first. So for example, if you're joining a new team or a new organization, or you're using a new code base, maybe you inherit it from another team, or you're looking at an open source project you might want to contribute to. And you'll have to figure out, what does this code do? If you're on a team, or if someone is joining your team, you can hopefully do short sessions giving an introduction to a code base. This is what we did on one of the teams I was on in my previous job. We would give an introduction of, this is what this application is about, this is why we use it, this is the place in the landscape, other applications we communicate with, where we get our data, where we send our data, all of that stuff, maybe a little bit of context of we are actively developing this part, or we're actually mostly maintaining this. So basically a summary or Cliff's Notes of the application. But obviously a good place to start is also to actually check out the code and have a look at it. This is also a good first test if you're on a new team or a new company, to make sure that you have access to all of the repos and that you can actually clone them. And then, of course, our IDE can help. I'm going to use my favorite IDE, which most of you will probably use as well. If not, some of the features might be different in whatever IDE or editor you use, but the same principles should apply. So let's say, is this clear in the back? Yes? Okay, thank you. So let's say we have a small Spring application. I'm going to use the pet clinic as an example. One of the first things I might do is just to look at the source code and see how many packages there are, what code is there. So here we see that we have some packages that are more in the programming domain and some that are more in the business domain. We have an idea of the kind of entities that we're dealing with. So already we have some idea. It's a pet clinic. We have pets, owners, vets. So we have an idea of the domain that this deals with. The next thing we want to do is maybe see if we can actually build the project. I'm going to use Maven Verify. If I use Maven Clean Install, Andres Almerai will run in the room and yell at us. So this is the way that I normally would build a project. So I'm going to see if I can build the project in this way. There might be a similar command for Gradle. I'm mostly a Maven user. So make sure that you can actually build the project and that you know how, especially if you're going to be working on it. Always make sure that you can build the project and the tests pass before you make changes, because otherwise if you break it, you have to go figure out whether you broke it or it was broken all along. So we have build success, yay. Let's say that wasn't the way to build it and I have to figure out how to build it. Hopefully that information will be in the README. If you don't have that in your README, please add how to build the project, how to run the tests, maybe what additional stuff you need. I worked on a team where we had several microservices and each was built in a different way. One was a Spring Boot, one was still on Spring, one was using Tomcat, one was using Jetty. And I'm too old to remember all of that. And in the meantime, the README was literally, this is the repo for this project. Super useful, thanks. So one of the first things, even though we are reading the code to understand it, one of the first things I did on that team was add a README to each one. How do I build this project so that I wouldn't have to remember? Hopefully the people who joined after I left that team found that useful. The next thing, something I like to do is to look at the POM XML to see what kind of dependencies a project uses. I would like to see whether they are the kind of libraries and frameworks that I'm familiar with, or maybe there are some things that are new. I can add those to my list of things to research. Also, I try to look like how up-to-date are the dependencies. I know we're not going to judge, but it gives me an idea of where this application is and what I'm getting myself into. And maybe if I can help improve that. I did another talk on dependencies in the past. Another thing we can do is to actually run the application. It's also good to know that you can run the application. So again, before you make your changes, or once you're done with your changes, you can start it up locally and hopefully test out whether your changes have the intended effect. We test our code, right? Thank you. So we can start the application. And if we have the application running, then we can also have a look at what the application does. So this is a pet clinic. We can find owners of the pets. We can find vets that can treat our pets. And because this is a Spring demo project, they have an error endpoint that shows us what happens if you throw an error in a Spring application. So if your application is throwing an error, obviously we can look for the error message in our favorite search engine. Not all error messages are equally helpful, but if you're using AI Assistant, you can also ask AI Assistant to explain a runtime error to you. I did a talk on AI Assistant yesterday that you can catch on YouTube. It's already out. They're very fast. So that's another way that, that it can help. So we looked at the project structure, building and running the project, the README, the dependencies, and I forgot to show you diagrams. Yeah, not in there, obviously. So if you have a very large application, the diagram, a generated diagram might not be very useful. We can select a different scope and create a diagram. So now we have a diagram of the classes in our application. It can be useful to have a diagram. I tend to also draw lots of diagrams. Feline actually recommends you draw your own for two reasons. Or one of my reasons is that if you draw your own, you can draw one for the area that you're actually interested in, whereas a generated diagram will have everything and you might only be interested in a part. Feline recommends drawing your own because you retain the information better if you draw your own diagram. So if you draw your own diagram, you'll better remember the information over looking at a diagram that someone else generated. But you can still use generated diagrams as input. Now, if we have a much bigger project with lots of modules, I'm going to use Cucumber JVM as an example because it's an application or library I'm familiar with, and I know it has a lot of modules. So in this case, we might not even know which module to get started with. A module named core might be a good one, but we might want to figure out how all of the modules are connected. So what we can do is we can generate a matrix that will give us the dependencies between the modules. I don't really care that the code is outdated because I just want to show you what that matrix looks like. So as you can see, we have a matrix and we have the same modules that we have in our project structure, but they are sorted differently. The modules that are used by other modules are sorted towards the bottom, and the modules that use them are sorted towards the top. So we can see here in the matrix which module uses which. Obviously, the rows and columns are the same, but the column names have been omitted. And we can hover over them to see, okay, this module uses that module. The blue boxes are the dependencies. Can you see the blue in the back? Okay, thank you. Otherwise, I'd have to switch to light mode, and that attracts bugs. So there's a little legend here that explains what this matrix is like. So we see that a green dependency uses a yellow dependency. So if we click it, we see which uses which. So that gives us information. So we could go through the matrix to figure out how they're all related. And we could use that to draw our own diagram. Or we can ask for this diagram. We have a project modules diagram, and that gives you one side of that equation. So this module uses these modules. So you could use those to create a diagram of the information that you need. Outside of the IDE, we can identify components, relationships and dependencies, concepts that we might need more information on, and gain context for that application. How is it developed? Why is it here? Where are we going with this? What are maybe the areas that I should be focusing on more or less because we're actively working on it or only maintaining it? Another way to familiarize yourself with an application is by looking at a particular slice of the application, so related to a particular use case, or simply tracing the control flow through the application. So for that, we need to find a starting point. And that starting point can be either generic, like a main method or an endpoint, or it can be very specific, like an error message or an exception that is thrown, something you see in the logs and you want to figure out where that comes from, or of course specific logic or functionality that you need to either debug or change. Obviously our IDE can help with that. So we could look in our application for the main method, which if we use search everywhere is quite a lot. So let's go to the pet clinic application. Obviously if you're a Spring user, who's a Spring user? Quite a lot of us. You know that if you find the main method in a Spring application, that's where the Spring magic starts. So maybe not the best place to start tracing how your application works unless you want to figure out how Spring works. So in that case, we might look at an endpoint. So let's go to the owner controller. Here we can see endpoints. So you might pick a particular endpoint and then go from that endpoint outside into the application and see where that takes you. So this is a fairly small application, so there's a controller that goes straight to the repo. You might have a service layer in between if you have a lot of business logic, but we can trace it outside in and back up again to give you an idea for a specific use case what's going on. You can also look at the endpoints tab to see all of the endpoints and get more information like the OpenAPI specification, documentation, etc. So different ways of looking outside in. Alternatively, we could be looking for, I forgot to close my stuff while I'm practicing. So let's say we're looking for where a particular error is thrown because you see an error either in your console or your logs. You can figure out where in the application you are, so kind of you are here pin in your project structure, and then you can trace it inside out, like how did we get to this error, what method was called, and figuring out the behavior from there. Obviously, knowing how to search and navigate in your IDE is a good help because then you don't have to think about it, so familiarize yourself with how to do that. Searching and navigating. So strategies outside of your IDE can be also to look at a particular use case and to draw your own diagrams. I also sometimes write down control flows of this calls that, just to see what happens where, to help me reason about it. And finally, we'll end up with a specific piece of code that we need to understand. And of course, one of the things that we can do, if you find a piece of code that is completely overwhelming and you have no idea where to start, you can use some of the structured exercises. You can use the first glance exercise. Just take 1 minute, just see what jumps out at you and why, and that will give you a place to start. Obviously, your IDE can help you with that as well. Let me go through this application. So if you're reading code in your IDE, as opposed to a printed piece of code, your IDE gives you lots of hints. So we have syntax highlighting, inlay hints, like usages and type info. And if we don't have that information, we can also pull up documentation or a quick definition of what that class does. I see that this one doesn't have any documentation, so we can generate some so that we can see that in the quick doc. So now we have a description for this class that we can pull up where we need it. So that solves a bit of the lack of information problem. We have inlay hints for types, but if we don't, we can also pull up type information. So there are lots of little hints that our IDE can give us about the code. As mentioned, we don't read the code top to bottom. We look at the structure of the code. So white space can actually help us make sense of the code, which means if you're writing code, use the white space to group it, because it helps us look for anchors in the code for the thing that we're looking for whatever reason we're working on. Obviously, if we're writing code in the IDE, it's auto-formatted, so we don't have to think about the formatting. But if we find code that is not properly formatted and we're reading it in an IDE, we can, of course, reformat it, which we can't do if we're reading it on a piece of paper. We can also change the order of methods if we want to sort private methods and public methods and have the public methods on top. So we can, even though the idea was to understand the code and not necessarily to change the code, if we're reading the code in the IDE, we can sort of play with that code to help us understand things. Let me quickly look at my cheat sheet. Right, so we look at the structure of the code. We can actually collapse the code if we want to only look at the methods and not be overwhelmed with all of the details, just to get a quick overview of a class, for example. We can also look at either the file structure, which we can also use for navigation, or at the structure tab. So different ways that we can look at the structure of a class before diving into details to have a kind of an understanding of what's going on in a particular class. We can, of course, look at the tests to get an idea of the intended behavior of the class. Hopefully your test names describe intended behavior, so what the application should be doing, because A, that gives you documentation of what the code should be doing, that you can actually run to make sure that that's how it works. But B, if they ever fail in the future because you made some changes, it will give you a quick hint of what the code should be doing, which makes it easier to figure out whether what you want or whether your changes actually broke something because you broke existing behavior that you need to keep, or whether maybe you overlooked some changes or some areas that might need to change. I've literally found tests called test scenario 1, test scenario 2, test scenario 3. Those are not helpful names at all. If they fail in the future, now I have to read all the code and figure out what it's supposed to do. And if I need that information to figure out what the code was supposed to do, that's not very helpful. Another way that we can see how the code behaves is by running it through the debugger. I very much like to actually see what it does over reading it and knowing what I think it does. So if I see it, it makes me more confident. So we could run the code through the debugger. I should have already set a breakpoint that it should hit. So if we run it through the debugger, once it hits the breakpoint at whatever point in the application we're interested in, we can see the state of the application, we can see the state of our objects, values of variables, we can see them either in the editor or in the debug console, we can see the stack trace or call stack. We can step over a method or step into a method, so we can follow along to see how the code behaves and observe the state of variables, etc. We can also, a feature I find super useful, we can evaluate expressions, even though we have this information in the editor and the debug window. This is also an editor, so we can evaluate different things. Let me stretch this window. So we can evaluate different things that we don't already have in the debug window and, for example, try out other stuff. I find this extremely useful if I'm trying to fix a bug and I want to quickly find out whether what I think would be the solution is actually the solution, and then I can go apply that to my code. There's way more that you can do with the debugger. I highly recommend that you familiarize yourself with how the debugger works, because that will help you when you have a production incident, which is not, anyway, stress is not the best for me if I'm trying to learn new things. So try to learn that before you actually need it. So as we are playing with the code, we might also want to try and refactor. I know we said again that we are trying to understand the code, but playing with the code might actually help us. So we could break up code into smaller pieces. Let me find the piece I wanted. So for example, here we are, if the payment failed, we are canceling order items. So instead of having this deeply nested, we could extract a method and give that a meaningful name, like cancel item. So by adding meaningful names, like breaking up a larger method into smaller methods and giving them meaningful names, that can help us make sense of what's going on in the code. And then we can either inline variables, or alternatively, we can extract variables and give them a meaningful name. We can also use refactor rename. Not all variable names are created equal, so as your understanding of the code grows, you could try to rename the variables to match your understanding. We can get AI-assisted to help us with that if needed. So just playing with the code and breaking it up into smaller pieces can help you while trying to understand the code. Obviously, we want to roll back those changes because we made them for our own understanding, not necessarily to change the code. We might want to look at the context of the code and see maybe why particular changes were made in the past. So we can look at the Git history and go into the history and see why particular changes were made to the code base. In my previous job, we would add the Jira ticket number, so we could go to Jira for more information on the user story of why the changes were made. Hopefully you have commit messages that describe why changes were made. If not, we can ask AI-assisted to explain commits to us as well. So, make sense of why a particular piece of code was changed. And finally, we can also get AI-assisted to explain code to us if it still doesn't make sense. So select what code we want to explain and ask an AI-assisted to explain that to us. It's great at summarizing stuff. So yeah, many ways that basically your IDE and AI assistants can help you make sense of code. Yeah, so structure, hints from your IDE, tests, debugging, refactoring for understanding, kind of playing with the code, maybe adding some tests to run through the code and verify that your understanding is correct, looking at the context of why the code is the way it is, when was it last changed and why, and lots of features for AI assistant to help you understand code. One more I forgot to show you. Who likes working with regex? Yeah, there's always some of you. Why? So there should be a regex somewhere. Yes. So for the rest of us, AI assistant can help you with that. Yay. So it was just, I saw today on Twitter that the plural of regex obviously is regrets. So yeah. I think there's an XKCD, I have a problem, I fix it with regex. Now I have two problems, yay. So outside of our IDE, structured exercises can help us make sense of the code. Felina's book has a lot of exercises that you can apply to your code base. If you can't find a group of friends or colleagues to have a code reading club with, you can use those. Memory aids like dependency graphs or state tables, drawing diagrams, etc., but also gaining context of the application of why is it the way that it is, where are we going with this. So what's next? Maybe if some of you are interested in doing a code reading club, the official code reading club do online events. I forgot to check whether they have any scheduled at the moment. They haven't for a while, but they have a bunch of resources on GitHub that you can use to start your own. So if you have your team or people at work or developer friends, all of my friends are developers, you can start your own club. They have resources for, I think, at least 3 or 4 sessions with a code sample, exercises to do, and notes for a facilitator on how to run the club. Again, Felina's book has a lot of exercises, and I recommend it anyway. Obviously, let your tools help you, but don't forget to use your brain. I'm a little under time, but that means there's time for questions. You can find, as promised, all of my slides and related materials on my website. Thanks. So let me know if there's any questions. If not, you can find me around the conference until tomorrow, or if you have any questions about our products, find us at the booth. Thanks.
All systems are nominal. Initialize Genesis